Hey guys and girls, welcome to True Faculty, your one-stop destination for all your skills needs, be it upskilling, cross-skilling or reskilling. This short video is about Python, data science and doing data science in Python. This video will also provide a preview into one of our successful courses with the same name, Data Science with Python. Let's talk about Python first. Why Python for data science? I'm sure most of you might have already known that Python is a powerful and proficient language to do data science. The reasons being Python is a lot expressive and Python does not impose trivial rules to guard the language. These two are important aspects to choose a language for a data science project. And most of the complex of tasks can be achieved in Python using simple and few lines of code. One other important reason for Python being popular among data science projects is that Python is supported by an incredible community that enriches and adds newer libraries to Python almost every day. If you want to learn about Python, please check out our introductory and advanced Python courses. Now that's about Python. Before we get into the details of this video, let me take a few moments to introduce myself. I am Jeff, the host of this course. I am a practicing data scientist, an architect and a mentor. I've been part of the industry for the past 15 years, doing a lot starting from programming for JVM as a Java programmer, moving on with big data technologies like Spark and Hadoop, and practicing languages like R, Scala, Python, and Julia for data science. I'm an architect now, and none of my architectures go without a data science component. I'm a passionate mentor. I've been mentoring people on technologies for the past 7 years, and I'm mentoring on machine learning and deep learning for the past 4 years. We have created 200 plus data scientists. And apart from this course, I'm also interested in other training areas like blockchains and applications development on blockchains, data science with Scala, Scala being another powerful language to do data science, big data analytics using Spark and Kafka, the program that focuses on creating reactive applications that deal with streaming data. So that's about me. Time to get into the details of the video. We have 4 sections of this video. The first 2 sections introduce and talk about data science and its relevance in the industry right now. Then we look into the course contents, and finally closing with a demo of an interesting machine learning algorithm solving an interesting industrial problem. So let's get started. What is data science and why is it called the sexiest job of the century by Gartner? By definition, the process of creating insights into data is called data science. So you have data on one side and insights into another. Now talking of data, data can come from various sources, most of them conventional, the sources like databases and files, and other data can come from unconventional data sources like the smart devices that we connect and use on a day-to-day basis. So talking of insights, the insights into data can lead us to very interesting observations of the business. It can tell us the trends of the business, and it can also help build other business products based on our understanding of the data. So how do we gain insights into data? There are analytical methods to do that. The analytical methods include the machine learning algorithms and deep learning algorithms that have been developed over years. So Data scientists apply analytical methods like machine learning and deep learning algorithms on data to get insights, to gain insights. Now, does it stop with insights? Where do we go next? Data science as a project does not always stop with insights. Insights are mostly converted into actions that can benefit the business. So the actions can be as simple as a data scientist providing a session on the insights, or the insights tuning into future business products that benefit the business. So that is data science for you. Data science is gaining insights into data using analytical methods and tuning the insights into actionable items. Now let's look at a couple of examples from the industry that are data science products. The first example is from a retail company that has built a product to look into its customers' details and the items that the customers have bought to find out if a customer is pregnant, and later on shipping coupons for post-pregnancy products like cribs and diapers, etc. The methods they have used is classification algorithms and decision trees to arrive at the conclusion that a customer is pregnant. So this is an interesting industrial problem that uses data to gain some insights, and the insights are converted into actions, and they use powerful analytical methods in between. Another interesting problem is again from a company, again from a retail company. The company uses 20 plus years of sales data to find out what customers would buy a week before Christmas. That's very important because the company has decided to pre-order the items, to design coupons and campaigns based on the items that the customers would be interested before a week of Christmas. And they have actually built a recommendation system to do this. So these two are powerful examples that comes from industry for data science, and how the insights into data has helped the industries to grow. So in the outset, data science is a process of creating insights into data using analytical methods and turning the insights into actions that benefit the businesses. So moving on, we now discuss why data science is relevant to the industry today, and what is it that makes data science a hyped topic to talk about. There are two aspects to it. Number one being the data itself that needs something like data science to be acted upon, and the other is the actions that the data science can create. Now, to give a sense of data, 90% of the data in the world today are generated in the last 2 years. So we are in the process of creating so much data, and we have only created 10% of the data in the world before 2 years. The rest of it created in the last 2 years. Another study states that by 2020, we'd be creating about 1.7 megabytes of data, of new information, every second. That is huge data, right? And it would be bad if we don't put those data into good use for the businesses. It's also estimated that within 2 years, the planet will have 500 billion smart connected devices. And those devices are going to generate more and more data. So we are talking about humongous rise in the data generation, and without putting those data into use, there is no need for the data that is generated. Now going to the actions. It's been estimated that if a company increases 10% of its accessibility into data, that can result in an increase of its income by $65 million. That is huge. Just by increasing the data accessibility by 10%, it's going to increase the business income. Another study states that the retailers who can leverage the full power of big data can increase their profit margins by 60%. And we're just talking about few industries here, and there are many industries out there that are waiting to be benefited based on the data science and its usages. So these factors make data science a very relevant field, and that's the reason that it's much hyped now. Moving on to the skills and jobs that are putting data science into perspective. We'll first talk about the jobs. Data scientist jobs and the demand for it would increase by 28% in 2020, which is more than a quarter of the data scientists today. It normally takes 34 days to fill out a big data position. That the fact comes from LinkedIn. It's going to take 53 days to fill a position, for a data scientist position in 2020, which is a humongous increase of 50%. So it means there is going to be more vacancy, there's going to be more demand for data science jobs. And holding a data scientist job is equivalent to holding a manager's or the lead position. This is stated to tell you how important the driver of data science is. Now, what are the skills that you need to perform a data science role or to become a data scientist? First, you need to be well versed with machine learning and deep learning, and an understanding of artificial intelligence is definitely going to help you. And you need to be well versed in one of these languages, namely Python, Scala, R, and Julia. One of these languages you need to be well versed in. Python is leading the race because of its simplicity, expressibility, and the ecosystem of open source libraries that are coming up every day in Python. So that's the reason Python is leading the race. So now that sums up why data science is so relevant in the market today. Now let's still talk about two positives on the skills perspective. So now the first question I ask you is, do you really need to shift to a new domain to exercise data science? The answer is no. You don't have to switch domain to become a data scientist. The domain that you are in currently, if you are an expert in the business, you are the best fit to become a data scientist, because you know your data. And by looking at the data, if you can find deviations and spikes, that by looking at the data, you gain confidence that something can be derived from this data, you are fit than anyone to become a data scientist in your domain. And that is very positive, because data science as an interdisciplinary field depends on the domain intelligence and domain knowledge that can be only achieved when you are in a domain for a long time and you know your data. So that's very positive. So with that positive, we'll move on to answering one important question: what story can you tell from your data determines how well you can play the data scientist role. Now, what does it take to become a data scientist? With true faculty, it takes 40 plus hours to become a data scientist. And Data Science with Python is an excellent course that we have designed for data science aspirants. And 80% of the course is driven by examples and practicing real-life industrial problems that in one way or the other teach you the benefits of being a data scientist and the benefits of digging out information from data. And the most exciting news is we'll be working on most of the amazing Python libraries out there, the libraries that is helping in and out data scientists every day to bring out the importance of a particular data set. So having said that, we'll now move quickly to the course contents. The course is comprising of 15 sections with 2 bonus sections. The first one starting with data science and its relevance. So this talks about how does data science establishes itself as a field, the role of data science and data scientist in a team, that we'll talk in depth about it, the goals of data science, how and why a company should invest in data science, and what are the goals of data science. Most importantly, we'll talk about the data science pipeline, which determines what is the end goal of a particular data science project. We end the chapter by discussing 3 phases of data science and some sub-phases in those 3 phases that we'll be using across the program. Now moving on to the second section, which is becoming a data scientist. The first steps that you would require to become a data scientist. We're going to discuss about the sources and ways of big data. Big data is the prima phase of any data science project. We also need to talk about the significance of storytelling. Data science is all about telling stories in and out of a data. So what is the significance of telling a story from data? We're going to talk about that. We're going to also talk about asking the right and relevant questions, and what are the questions that constitute a relevant question to data sets. We're going to discuss about that. And every data scientist is also an experimentalist, and we're going to talk why is experimentation an important aspect or the essence of data science itself. And data science will lead you to some of the insights of data, and that will drive confidence in business. And how does it drive the results, and how does the results drive confidence? We're going to talk about that. That would end the second chapter. Moving on, there's no data science without statistics, right? Data science builds on statistics in most of the ways, and a statistic refresher will help us dig into data in the most comprehensive way. And this chapter starts with discussing the types of data and statistics. It discusses mean, median, mode, variation, standard deviation, probability, percentiles and moments, covariance and correlation. Most importantly, it talks about conditional probability and ends up with Bayes' theorem. Statistics is one of the core pillars of data science. So this chapter is introduced to help students to gain the statistic knowledge. So just by applying statistics, the results can be way different and very rewarding. Now we move on to introduction to machine learning. The chapter opens up many questions about machine learning and answers them comprehensively. It talks about the types and uses of machine learning, the examples of machine learning projects, the best practices of the industry, and it talks about model building and feature engineering, which is exactly the essence of machine learning, that is to extract features from the data sets. We're going to talk about how to extract features, how to extract good features, and we're also going to talk about how to lay these features as a pipeline so as to drive a data science project towards its desired end goal. So that finishes with the introduction to machine learning. We move on to predictive analytics, an important division of machine learning that helps us predict an outcome based on a single variable or multiple variables. We're going to open up a discussion on regression algorithms, and regressors in particular. We're going to talk about the accuracy and modeling of regression algorithms, how best fit they are. We're going to build linear, ridge, and polynomial regressors. We're going to build multivariate regressors. And at last, we'll talk about multi-level models, laying these regressors in multiple levels so the regressor benefits from its previous level regressors. We move on to classification, predictive analytics algorithms. We are going to talk about classification and classifiers. We'll build few classifiers, namely simple, logistic regression classifiers, naive-based classifiers. Then we talk about how to introduce k-nearest neighbors into classification, how it can benefit us. We move on to creating better predictive models, and we are in predictive analytics still. So we'll talk about how to create predictive models, and creating predictive models is with always the support of support vector machines or SVMs. We're going to build a linear classifier SVM, a non-linear classifier support vector machine, and it's always challenging to find a right support vector machine for supporting. We're going to also get introduced to the powerful kernel SVM, and least we are going to talk about tuning SVMs for better predictions. Now, moving on, we're going to talk about ensemble learning, which is about decision trees, and what are decision trees and what are the different decision tree algorithms that can be put in use. We're going to solve problem of overfitting using decision trees, and we're going to talk about few concepts that decision trees support to solve, namely bagging, boosting, and stacking. We're going to talk about random forest as an algorithm that works on estimators, and we're going to create random forest regressors, and at last we're going to use cross-validation to find out if a decision tree has solved the problem in a better way. We're moving on to clustering of data. When you have too many data, and it's a good idea to cluster them into groups, so to rule them. So we're going to talk about using k-means as a clustering means to cluster the data. We're going to use TF-IDF, an important note on k-means. We're going to talk about vector quantization and imaging techniques. So visually, we could say this clustering algorithms works well or not. We're going to talk about clean shift clustering with examples. We're also going to talk about agglomerative clustering, which is an important new field that is coming up with clustering. We're going to talk about Gaussian mixture models, and we're going to analyze and evaluate all these algorithms based on their performance, and we're going to understand how to evaluate them for performance. Moving on from clustering data, we're going to build and learn and build recommender systems. To start with, we will learn what is content and collaborative filtering. To build a recommender system, you need to filter data based on the content and how these content collaborate. The collaboration can happen on user or item based. We're going to learn about that, and we're going to build a collaborative filtering model, a recommender system that helps us in recommending few results of an analysis. We're going to talk about latent factor, the challenges that introduces in the recommender systems. Not least, we're going to improve the recommender result using the best practices in the industry. Now moving on, in a multivariant system, it's always good to associate variables, and that's when association comes in. We're going to understand why association plays an important role in data science. We're going to understand how market basket problem helps us in solving association. We're going to introduce the beautiful a priori algorithm, which associates variables. We're also going to talk about other association algorithms, and we're going to find out the best recommendations to using association rules. So moving on, we'll talk about the better ways to work with supervised algorithms. So we're going to talk about training and testing, which essentially is the splitting of data sets. You take up a data set and try to split into training data sets and testing data sets, and how well you could do that. That's going to estimate the performance of your model. We're also going to talk about evaluating the accuracy of the supervised algorithms using cross-validations as a technique. And we're going to use confusion matrix to visualize the performance and evaluation of algorithms. We're going to extract the performance reports. So ideally, a data science problem, at the beginning of data science problem, you will use one algorithm, and you will also use multiple other algorithms and find out which is performing better. And you need to know how to extract performance reports from the confusion matrix and the cross-validation techniques. And we'll also learn about validation and learning curves. Few models learn faster and few models learn late. So we're going to find how to determine this learning aspects of a model and algorithms. So far we talked about labeled data, and we'll talk about unlabeled data and how best it should learn. Unlabeled data, we're going to talk about principal component analysis, or PCA. In some cases, you'll be given with unlabeled data sets, you don't know what is what, but PCA is one important technique that you could put to use to find out some learning from the data set that you're given with. PCAs can be used well in dimension reduction. For example, let's say you have 10 variables and you want to reduce the problem with let's say 2 variables. You could do that with PCA. Choose 2 variables. And PCA can also be used for noise filtering. So when you're given with unlabeled data, you do your principal component analysis, or PCA, and then move on to other supervised algorithms based on the result. Moving on, NLP is very famous these days. We'll talk about text data analysis. We'll talk about tokenization as a pre-process to process text data. We'll talk about stemming and lemmatization to create a base text data. We also talk about chunking, which is to divide text and rule. We also talk about one of the interesting text data analytics model called bag of words. We talk about text classifier, which is again important for sentiment analysis. So to prove that your learning model is sentinel. Yeah. So there is eventually the topic modeling and patterns that you could evolve from a text data analytics platform, which we'll talk about that. The last chapter talks about time series and sequential data. So if you talk about few markets like the share marketing or the banks, they always deal with time series formats of data. So the data is time bounded. The data that is valid today may not be valid after a couple of seconds. So how do you deal with such data? And how do you slice the formats? And how do you operate on time series? How do you extract statistics? So this mostly leads to the trend that comes up with the data. And there is a beautiful model called hidden Markov model you could generate from the sequential data, the time series sequential data. And you could also understand a lot from sequential data based on the conditional random fields, which you could pick and play to get the most of the sequential data. Now that would end the contents of the data science course, the 15 chapters that completely explain, put forth all or the most of the data science perspective and algorithms before you. And before we close the chapter, or before we close the course, we talk about what's next in data science and where could you go next, meaning what are the different areas, meaning the deep learning algorithms that you could do, that we talk in this chapter. And most importantly, we'll also talk about how you could crack interviews of data science. I'm sure data science is an excellent career move, and this chapter will help you how to crack interviews. It would give you examples of interviews that happen. It could give you what questions you could expect in a data science interview. So said that, you can download the course contents from the truefaculty.com website, or give us a call. There's also an email address where you could send a question or asking us the course contents. Please visit truefaculty.com. That could be a one-stop destination for all your skill needs going forward. Now let's take a peek into an interesting ML algorithm solving an interesting business problem. Stay watched. Thank you. Welcome to this demo. What you're looking at is the hide history from a company, the hide hit rate, right? So the CSV file or the comma separated files has 7 columns. The 7th one being whether a candidate is hired or not. The first one is the years of experience. Second one, if he's employed when he applied for the position. The third one is the number of years he spent with his previous employer. The fourth one is the level of education, whether he's a graduate, master's, or a doctorate. The fifth one is if he's from the top school. And the sixth one is if the candidate has interned with the company before. So using this, we are going to predict for a given candidate what is the probability that the candidate will be hired. So we are going to use decision trees and random forest with estimators to solve this problem. So stay tuned. I'm going to use a Jupyter notebook to solve this problem, and most of the problems in the codes will use a Jupyter notebook. So a Jupyter notebook is a good way to solve a problem, a data science problem, along with providing a useful documentation for it. So that's what we're going to do. Stay tuned. What you're looking at is a Jupyter notebook, the most prescribed way to solve data science problems along with documenting the same. So let's use decision, as discussed, we are going to use decision trees and random forest estimators to predict a higher hit. Now before we start, we need to load the CSV, and this is what we're going to do, and this little button will help us execute this set of code. So we're going to use languages, so the libraries like NumPy, Pandas, and scikit-learn for this problem. So let's run this section of code. We run it. Let's display something has been loaded from a CSV file. Let's display the head of the load that has happened. Oh yeah, so far so good. So we have loaded the CSV successfully, and what we're displaying is the first 5 rows that are loaded, counting on from years of experience, employer, previous employees, level of education, top school, intern, and hired. Now for the decision trees to work, we need to have numerical values. So we're going to supply some numerical values to all this textual data that we have here. For y's, we are going to supply a numerical value of 1. For n, we are going to supply a numerical value of 0. And we're going to add some weightage to this level of education. So for graduates, we're going to give a weightage of 0. For masters 1 and doctorates 2. So this numerical designation is left for the data scientist to decide. So for this problem, what I've decided is to use this weightage. So I've quoted the weightage here. So let's apply the weightage to the loaded rows and display the head again. So here we go. So far so good again. So now I've displayed the weightage. You don't see any textual data now, and all the textual data has been provided with a numerical value. Now we want to find out the hide hit for a candidate. So all the other 6 attributes are the features. So that's exactly what we're going to do. So let's load it to a variable called features, and so there you go, we have loaded all the features. Now let's construct a decision tree classifier. So what we need is the hired hit, and what we are using is these features that is part of this feature variable. So let's create it now. Let's run this, and we have run this. Now the decision tree has been created, but we cannot see it. So to to see it, we are going to print that dash entry onto a PNG file. So this is the code for it. It's not a very difficult code, but just it tries to extract from the dash entry and prints it onto a PNG file. Yeah, there we go. So we have printed it. So it says that, okay, if it's the interned ratios below or equal to 0.5, there are more chances to be hired. And then you go to look into the other variable called employed. If the employed is more than less than 0.5, then go to areas of experience, then top school, then finally decide whether the candidate is hired or not. So now let's try to regress it with 10 different dash entries created. So we could use a random forest classifier with this 10 estimators. So this estimators is very important because we're going to put in 10 different dash entries to predict the classes. Again, 10 is a number. You could do 20, 30 based on your need. So let's create the random forest classifier. There we go, we have created it now. Now let's predict it. Now to predict, what we'll do is we'll say print CLF dot predict. The first column is years of experience. We'll say 20 is the years of experience, and if the candidate is employed, yes. And the previous employer, he stayed 10 years with the previous employer, and his education is a doctorate, and he's from a top school, and he's interned. So let's see what happens. Let's try to run it. There you go. The result is 1. So more likely the candidate is hired. Now let's go to another example. Let's copy it and paste it to the next level, and now let's change it. So let's say 10 years, and it's not working currently. Previous experiences, previous employer is 1. He's a graduate, and he's from a top school, and his intern is here. Now let's see what happens. He still hired as 1. So now what we have built is we have built a random forest classifier to predict the hide ratio or hide hit for a candidate using the history of hires. So that's pretty much it for the demo. So that brings an end to this short video. So hope you have enjoyed the video. Thanks for your time. And you're listening to True Faculty's Data Science with Python course. If you're interested in the course, please talk to us. Please log into truefaculty.com and please talk to us. And if you have any specific needs for training, please do let us know. Thank you so much for your time, and all the best for your data science aspiration. Thank you.